Talk some more about what we were doing last time was converting regular expression to NFA, right? And I promised I had one that I wanted you guys to try. So this is regular expression converting to NFA. Maybe I'll do one just to refresh our memory. There are three basic kind of structures that you need to remember. I suppose you should memorize these, although they're not really hard to memorize. If you want to do a plus, R1 plus R2, the way to do that is with two branching paths, where the first one goes through R1 and the second one goes through R2, and then they go epsilons back to some final state. There was also the concatenation. That is, if you want one thing just followed immediately by another thing, that is pretty straightforward. You just go from one with the epsilon into the next one. And then the maybe most interesting looking one, I'm going to try and fit these all on my screen, is the star. So if I have R star, to do that, you go through R, and then you also have an epsilon coming back to the beginning and an epsilon going forwards to the end. So those big epsilons on the outer sort of top and bottom allow you to go back and go through the R many times if you want to. And the one on the bottom going forwards allows you to skip the R entirely. That is, if you want to do the star like 0 times. All right. So, for example, if I wanted to make a fancy regular expression, how about A plus B star, something like that. So I want to think about each of these in maybe little pieces. First of all, let's do, once you're good at this, you can probably jump all the way to the answer, and that's fine with me if you want to do it that way. But A plus B, first of all, that would be this plus makes a branching path. So it would be like this, A on top, B on the bottom, and then coming back together with epsilons. All right, that's A plus B. If I want to do A plus B star, I'm trying to sort of build up in complexity to get the various pieces of what I'm looking for. A plus B star would be that same thing, but additionally having the epsilon going back from the end back to the start, and the epsilon going forwards from the beginning to the end. So A plus B star is this, sorry, with parentheses like that, is the same thing again. I'm just going to copy because I can do that. And it has an epsilon coming back to the beginning and an epsilon going forwards to the end. All right, that's A plus B star. And our final answer really is just that, but it has an A and the B on the front. So that also I can more or less copy and paste A plus B star. And it's, well, I start with A, then B, and then it goes into this thing. So actually this thing can just become this next state, or you could make an epsilon into this other one. So now I'm going to copy this bit right here. Ooh. There you go. What? I deleted it. Sorry. Right there. And this last guy should be the final accepting state. That's it. A plus B star. All right. In theory, any regular expression, you could build it up into an NFA like this. A big regular expression is going to generate a really big NFA, but this is how we do it. Any thoughts about that? I hope you remember how to do this from last time. All right, I got one for you all to try. How about make an NFA? Make an NFA for this regular expression. A squared plus B star BA plus epsilon. See what you think. I will give you a few minutes. I'll walk around and see how you're doing.
Oh, okay.
But anyway, a squared, you should think of a squared as just a, and then plus b. So it's like that, this thing here, that is a plus b. The a plus b, just instead of as a, we're going to state it there, a.
Oh,
Good? Mm-hmm. That's the a squared plus b. Okay. This has this a here, that's not. Yeah, put another statement, just a. Okay. Mm-hmm. I just saw this, it says this a here is not because this will, you want two a's. This will let you do one, maybe no more, or maybe many more. So let's do a's.
Doing all right? Mm-hmm. I think this is not quite the plus. This is just a.
Oh, wait.
Okay,
got
yeah,
it.
this is a plus. All right.
Yeah, that's a squared plus b.
Yeah. So yeah, that's what we quite work. To get plus, plus is always two branching paths.
Is it the plus of the
It's the plus of all of that. So really you want two paths from the very beginning, two paths. But this is one.
Oh,
Doing good?
awesome.
This is, I think you forgot the star. These guys should be in there. But then also this plus, oh, you just didn't write, there's a plus epsilon. Yeah. Makes it a little different.
Oh. This instead.
Okay. Yeah, I guess that works. I would, it's more typical to write the plus as two branching paths, where
So like,
along one, like across the top is AA, across the
Mm.
bottom is B. Yeah, and actually to make this star here, remember you need this epsilon going back, but you also need an epsilon going forward.
okay.
Star. How's it going? Oh, yeah, it seems pretty good. So the plus fraction is on this side. You put that here as the second path. Well, yeah, every time there's a plus, you need two branching paths. Yeah, but it's not two paths, like actually that's the thing. It's just epsilon. It's really two paths because of and the first branch is all that, and the second. So really it's like all of this is on one branch. And other branch. Yeah, from the very line, it's a branch, but this is one branch. So that's like all the work.
So I had I think it's branching like epsilon first, right?
Yeah.
But if that's accepted, then this has to be accepted.
Actually, yeah, it should be branching from the get-go.
And then this would branch here, but then because it's accepted in steady state, and this is just epsilon, would this also just be accepted?
So, you should make only this exception.
But isn't this like all this or E?
Yes, so,
Wouldn't nothing also just work just like being steady state? Because right, we have, this is what I had initially. From here to this, this is exactly.
okay, so typical way we do it is with this, don't make that exception,
Okay.
because that complicates things. Probably it's still.
This is the
Actually, it's not. Because this is, I think, you can go once.
You're missing the
back,
first,
but then, but that's not.
A squared.
Okay.
You need to, if you're gonna go through here, you must.
Oh,
do it.
that's going to that?
So-
Oh, okay,
okay.
alright.
Don't make that exception, and then these two, really it's two
So
branching
nobody
paths.
gets
So
one.
should we make them come back
Yeah,
together?
but it's
So
the
we
one,
get
this one, I didn't
and
look
this
at
one.
it's all
Oh,
of
okay.
this or epsilon.
All right, let's talk about them.
Yeah.
So it goes.
So you literally.
I see
share
some
all
people
of
doing
it.
pretty well. So you got to build it up in pieces. What's a little weird about this one is there are two pieces here with a plus. Like at the topmost level, what I have is a plus, where the first thing is a weird thing, and the second thing is epsilon. So what I'm going to do on the very large scale, what it is a plus, where the one on the bottom is just epsilon. The one on the top is all of that stuff, a squared plus b star ba. And then we go epsilons into the accepting state. So this is the large scale structure of what we're doing here. This is how you get a squared plus b star ba plus epsilon. To do the plus, you make two branching paths where the one on top is the a squared plus b star ba, and then the one on the bottom is epsilon. And how do I make that piece on the top, which I'm going to plug in, a squared plus b. So maybe I'll talk about a squared plus b first. That would be another two branches. Up top, I do a squared, which you have to write this way, aa, and on the bottom, I do b, which is like this. And then the two branches come back together. So that's a squared plus b. As I always say, you can perhaps abbreviate this a little bit by writing fewer epsilons. Certainly, it's not necessary to write all three epsilons here, but to me, that it's clearer to write it in that way. But if you want to simplify, that's fine. Anyway, this is a squared plus b. How do I do a squared plus b star? You just additionally add the big epsilons going forwards and backwards. So maybe, would you mind if I just write that in? A squared plus b star would be the same, but also having a big forwards epsilon and a big epsilon coming back. The burger type shape. All right, this is a squared plus b star. And now I want that followed by ba. Would you mind if I just write that in? That's not so hard to write in, right? You just, at the end there, make it do a b and then an a. So this will be a squared plus b star ba. It just has a b and then an a. All right. So my final answer will be all of this big stuff here plugged into that box. All right. So I'm going to see if I can try and draw the whole thing at once. It should be, here's my starting state. I go two epsilons. The one across the bottom is just epsilons all the way to my final state. And then the one across the top is that big burger from before. So I go, I'm just copying the picture that I see at the top of my screen right now. Oops. A, epsilon. This one is just B. And then I go B, and then A, and then back to this guy. And I need that sesame seed bun. There you go. This is my final answer. Something like that. Like I said, you can, there are ways to simplify the diagram, but I don't care about that at this point. Anybody got questions about that? I think as I was walking around, it looked like people settled on this eventually. Something like that. Okay, great. So we all know now how to convert regular expression to NFA. I would like to discuss, can you go the other way around? Can you convert NFA back into a regular expression? And the answer is yes, although it's quite a bit more complicated, it turns out. Actually, there's sort of if you read in our book about this, they say yes, it's possible to do this, but the details are kind of messy, so we're going to put that in the appendix. And there's like a whole chapter describing the details of exactly how to do this. What I would like to do is just talk about some fairly easy examples, and then I'll try and indicate what you have to do in some kind of more complicated situations. But I'm going to go the other way. T'other way. That is, can we convert NFA back to a regular expression. Actually, this is possible in general, and we're going to do mostly, I'll ask you to do some of these on the homework, but it'll be kind of easy examples because there are some that are quite difficult. So let's just try. I'm going to try an example. How about this is one actually that's on the homework for tonight, a little familiar favorite. On the homework, these states have names, and your job is to do the subset thing to convert into a DFA. I am not interested in doing that at the moment. And that homework question has nothing to do with what we're about to do. But perhaps you recognize this diagram from the homework. This is, I believe, the second question on the homework. On the homework, your job is to convert to a DFA, but that's not what I'm doing right now. I would like to convert to regular expression. All right? This one actually is fairly easy to do, to convert to a regular expression. What I want to do is just think about what are all possible strings that get me to the accepting state. So I have to imagine. Now on some NFAs, this is a hard thing to think about, but on this one it's not so hard. Imagine all possible paths from the starting state to the accepting. And in this example, this is easy in this example because all the lines kind of go left to right. And there are no loops anywhere, so it's actually fairly easy to describe what are all the possible paths. Well, you could go across the top, you could go across the middle, or you could go across the bottom. And really what this is, since this diagram is basically just three parallel paths, I can expect to write a regular expression in terms of a or with like three alternatives. It's either across the top, or across the middle, or across the bottom. So the structure here is there are three basic paths. So it'll look like, something plus something plus something. In this particular example, there are three basic ways you can get from the start to the accepting state. And we're just going to use the plus to combine them together, because the plus is what you do for parallel paths through the diagram. And can I say, maybe I'll do, the top one is actually the most complicated because it has those epsilons in it. How about the middle and the bottom? Those are less complicated. Can anybody say, so let's put the middle one right here. What regular expression should I use to match with things that make it across the middle? Yeah.
AB squared.
AB squared, yeah, or just ABB. This is not a trick question. The only way to go across the middle is if it literally just says ABB. That's it. So I'm going to put ABB here, or you can put B squared if you like. All right. What about the bottom? That's just BA. Right? And now the top is a little more complicated because of the epsilons there. There are actually a few different, like for instance, across the top you could do ABA, or you could do just BA, like the epsilon first and then BA, or you could do AB followed by epsilon. There are a few options, but actually I can use sort of or in a different way up there. So across the top I'm going to write like this: A or epsilon, B, A or epsilon. How do you like that? Those three arrows there, the first is A or epsilon, the next one is a B, and then the last one is A or epsilon. All right, so we converted that NFA into a regular expression. This is a very easy example because it very clearly has three parallel paths through the diagram. All right, any questions about that one? We're gonna do some more interesting ones. All right. Basically, these are going to be easy if there's if sort of all the arrows go the same way and there's no arrows going back to the beginning. If there are loops, actually in this diagram here, there are no possible loops like through the arrows. You can't ever make a loop in this example because all the arrows kind of go the same way. But I'll just say this is harder if there are loops. All right, so let's try some examples where there are loops. Still, we're going to do fairly simple examples just because these can be much, much harder. How about, here's some examples. How about this guy here? All right. Now in this case, the starting state is the same as the accepting state. So when I'm thinking about what are the different ways you could get from the start to the accepting, actually the question is really what are the different loops that I can do? Because in order to be accepting here, you have to end up back where you started. So looking at the diagram here, I say there's basically two loops, right, from the starting state. One is if you just do A, that's a little loop, or you could do ABA, that's another loop. So there's two loops, they look like A or ABA, right? And in order to end up at the starting state, so it's basically like A star or ABA star, but actually you can interchange, you can like do one and then the other. You could do A first, and then you could do ABA, and then you could do A again. You could do ABA 3 more times, right? The proper way to do this is I'll say A or ABA, and then either can be done several times in any order. Like you could do the A a few times, and then you could do the ABA a few times. Can we think how to write this as a regular expression? I'm going to use the star, because the star is how you indicate looping. Anybody got a big idea? Yeah?
Could you do A plus A star plus ABA star with all of that in the star?
Yes. I'm going to say something slightly different from what she said. A plus ABA, and then all of that in a star. All right? You go through the star means you can do this over and over again, and each time through the star, you either do A or you do ABA. That's how we do it. I think what she literally said was put stars here also and here. Now that is still correct, but it's unnecessary. If you want to repeat the A, just the A, the outer star still allows you to do that. So those red ones that I put in there are not, it's not wrong, but it's unnecessary. This gets the job done. All right, so to do examples like this, you have to analyze what are all the loops, and then basically put them inside of a star, maybe with plus in between them. All right, I got another one. Here's another one. How about maybe you'll get a feel for why these examples actually can be quite difficult if you had a really big NFA with just arrows going all over the place. It's going to be very hard to analyze properly all the possible loops in the diagram. All right. What I have here is basically two loops here. There's this one and this one, right? These are basically two loops. I will say when I look at the diagram, my analysis here is basically two loops. They are A or AB, but you got to do B first, right? In order to even get there at all, you do B first, and then you can do these one or the other of these two loops, and possibly both of them mixed up together. So how could I write that as a regular expression? You have to do B first, and then you can do either one of these loops. Anybody think you can make it happen? Yeah?
B, and then in parentheses, A or AB star.
Yeah, I like that. B followed by A plus AB star. All right? It's very much like the previous one, except we have to do B first before all of those loops. So this is the appropriate regular expression. Two different loops, but you got to do B first, right? How about, I got one for you all to try. I got two for you all to try. I'm in a you try kind of mood today. I feel like I've been talking by myself a lot lately. How about that? See if you can make this into a regular expression. This is similar to the previous one. And then I got one more. Getting anywhere?
I like this, although you shouldn't use N here in a regular expression. You probably mean star. But that's something. There's a little problem that this star could happen 0 times, which would be from here only to, but that's not allowed. Like it
Okay.
needs to
It needs one.
definitely have to be A. And then you can do more A's if you want to.
A and then A. Yeah.
A and then A star. Right. Yeah. Right. Yeah. Great. And can I say one more thing? Now that you have this, actually you don't need that anymore. You're redundant.
Cancel.
Yeah. I mean, it's not wrong, but. Doing okay?
What you got? Awesome. Sweet.
Yeah. That's perfect.
Awesome.
Mhm.
Sweet.
How's it going? Yeah, this is great. One comment. This is not wrong, but this is actually with that. Because this, it's not really the same thing, but this star could happen 0 times, which would give you AAB. Like if you want to get AAB, actually you can still get it. So you can just erase that. It's not necessary. But not wrong. Okay. That's great. That'll be the same thing. I'll just over to this. And now you have this one. Actually, that one is redundant because this already fits that timer. So you don't actually. Okay. Yeah, that's great. And one solution. You need to be able to do, I think differences a little weird. When you write it this way, the way the surface order operation works is it's either A plus B star or it's all this, which I think is not the A B following the coefficient of B plus C. What you got? Yeah, that's good. Uh-huh. Yeah, that's true. Yeah. Yeah, that's great. What you got? I think outside of this one should be another step. You could do this one, and then this one, and this one. So they all are equal to. That's good. And this, no. Could do A and
All right, let's talk about these. Sorry I didn't make it all the way around the room. I think it looks like people are doing great. So the first one is, first of all, it's got to start with a B. So I'm just going to begin with a B on the outside. And then followed by some bunch of loopy stuff with a star on the outside, right? And then what are the possible loops you can do? Well, first of all, you can just do A here over and over again. So that's one. Or you could do this more complicated thing where you go A and then some more A's and then back with a B. The best way to write that is A and then some more A's if you want to, and then going back with a B, like so. A star, B. I hope that's what you wrote. That's how I see this thing here. One very common thing that I saw as I was walking around, some people wrote, and this is not wrong, but it's just a little, this is a little redundant here because this AB, this is for folks who were looking at the picture and decided, well, you could just go A, B and just not do any of the extra A's. That would be this alternative. Or you could do some of the extra A's and that would be this alternative. But really, since this star here includes doing 0 repetitions in this position, actually this part of it already encompasses that alternative. So that this one, it's not wrong, but you might as well just not include that because that piece is redundant with the A star B. All right, great. And then the next one here. So this one involves loops before you do A, B at the end. So it's some kind of a bunch of stuff with a star around it and then finishing off with A, B, right? That's how I see the diagram here. And what is the stuff at the beginning? Well, the loops that you can do at the beginning, I would say you can do A here, or you could do B here, or you could do B followed by B. So there are 3 alternatives here, like that. A or B squared. I hope you got something like that. Now, some of you noticed, actually, in a similar way to the thing that I just said above, there is a redundancy here because I have a B, a single B inside of a star. That means you can do any number of B's. At that point, it's not necessary to also say you can do any number of B squareds, right? Because this B already can make any amount of B's that you want. You don't also need to say I can do any amount of B squareds that you want. Actually, even like the original NFA is redundant in that sense because rather than going B, B, I could just go B, B up here on the loop, right? So for that reason, actually, you don't need this right here. So it's not wrong the way I wrote it the first time. It's just there's some redundancy in the regular expression. All right. Is that a question? Yeah.
Question. I did.
Oh yeah. Let's do. I did this. Is it still right?
Yeah, and yeah, that's in parentheses A squared AB parentheses. Oh, sorry, A star instead of squared.
Okay. A star AB. Okay.
Plus. In parentheses B star AB.
Yeah. Let's see where this is going. Plus. Did you do another one? B squared. Star AB? No? Or just leave it at that?
I think, yeah, that's all I did.
Okay, yeah, this is, I think the idea is kind of like, this is kind of like my answer, but sort of like distributed if you had kind of multiplied through the AB on each part. It's either A followed by AB or it's B followed by AB, and that's each of these parts. Actually, this is not equivalent. Does anybody see the difference here? This says either you do a bunch of A's first and then AB, or you do a bunch of B's first and then AB. That's not quite the same as this. Everybody see the difference? Yeah.
You should accept like AB, AB, AA, like any variation of that followed by AB.
Yeah, it's because when you do the star, every time through here, you could choose the A or the B, and you could do the A sometimes and then the B some other times and then the A some more times. Whereas this here, it requires you to either only take the A every time or only take the B every time, and that's different. So this is.
My one is limited.
Yeah, this is. Yeah, you're missing out on some strings that should be accepted here. I'm trying to think of a way that you could make it correct, and I don't know. I mean, this is the way you make it correct. All right. Any other attempts? So, I mean, it is very possible. Sometimes you would write something that's different from what I wrote, and it's still correct. But sometimes it's not. Okay. So these are all the examples that I wanted to do. I hope that you can agree with me that it is with a very large NFA with lots of arrows going back, with lots of loops in it. It is very difficult to analyze all possible loops in a typical NFA, but it is possible, in theory, to do that, and then you can write out your regular expression, which somehow incorporates all possible loops in it. This is not easy to do if you're trying to do it by hand, but you could write a computer program to do this. Anyway, the moral of the story is we can convert NFA to regular expression. All right. When I ask you to do these on our homeworks or on the tests or whatever, they will be easy examples. I mean, like the ones we just did. But even on big NFAs, it is possible to do this. Okay. So put this together with what we were doing at the beginning of class. At the beginning of class we were doing, you start with a regular expression, you can convert it to NFA. So we can convert NFA to regular expression, and also the other way around, right? Also regular expression to NFA. That means these two things are really the same, right? Any NFA is equivalent to a regular expression, and any regular expression can be equivalent to an NFA. So when I ask a question about like what kinds of languages can you make with a regular expression, the answer is it's the same kinds of languages you can make with an NFA, because you can go back and forth. They're sort of interoperable. All right. So that means the languages expressible. I'll say, so the languages expressible by regular expression are the same as those of NFAs. All right? And there's a name for those languages. They are the regular languages. That's what we've been talking about. Basically, the whole semester so far is different ways of generating regular languages. So these are the regular languages. All right. So the big sort of takeaway from this is, so this is the word, the phraseology that folks in this area sometimes use to talk about this. They say the expressive power of DFA, NFA, and regular expressions are all the same. The types of languages that they can compute are all the same, and they are the regular languages. That's why we call them regular languages, because really the terminology regular comes from regular expressions, but it's also that's also the same category of languages for the finite machines, the DFA and the NFA. All right. The expressive power of these are all the same, the regular languages. All right. And at this point, we have pretty much said all that we're going to say about regular languages. I don't know if it's a letdown to you to talk about, we've talked about these three major different types of machines, and they all end up being more or less the same. They're interchangeable, right? We know how to convert NFA to DFA also. That's the subset thing that you're going to do on the homework. So actually, there is in theory a way to convert regular expression to DFA. I would convert the regular expression first to NFA and then go NFA to DFA. There's not a great way to go directly regular expression to DFA. All right. Anyway, for the rest of the semester, really, we're going to be focusing on non-regular languages. So the regular languages, sort of from now on, you're going to look back on all of this stuff as like the simple or the easiest kinds of languages. And there are more complicated ones that are not regular languages. I wanted to do one final example. Sorry, I don't know if I mixed my papers up. Probably I had intended to do that at the end. DFA, NFA, and regular expression are all the same. Remember, one of my favorite examples of a DFA was the DFA for binary divisibility by 3. right? A DFA which accepts only binary numbers which are divisible by 3 and rejects if it's not divisible by 3. If you believe all of this, actually, what all of this means is it should be possible to do this with a regular expression. There should be a single regular expression which generates all binary numbers that are divisible by 3. All right, so I want to see what that would look like. The DFA for binary numbers divisible by 3 should be expressible as a regular expression, which I think is interesting. I think it's easy to think of a DFA as individual, like an individual DFA is like a computer. It's like a very simple, very kind of stupid computer. A regular expression, though, is the same way. I would like to think of like this thing right here is kind of like a computer, even though it's, I mean, it's just a weird thing, but it has the same meaning as this, which is kind of like a computer. Anyway, this DFA should be expressible as a regular expression. Can we do it? So I don't know if you remember this DFA, but this is what it looks like. It had the first state like this. I don't have this memorized. I have it written down. That was the DFA for binary numbers and divisibility by 3. So how can I express that as a regular expression? It's slightly complicated, but basically I'm just looking at loops here. From the starting state, I could do this loop, a 0, just 0. So I'm going to put a bunch of different loops inside of a big star, right? And the first one I could do would be just 0. That's the loop just on the front state there, all right? What else could I do? If you actually go across the diagram here, you can do a 1. Well, let's first of all imagine I go all the way across. I could do 1, 0, followed by a bunch of 1s, and then 0, 1. So I'm going to write that as 1, 0, 1 star, 0, 1. Now I have to change some stuff around a little bit, but this is basically the answer. 1, 0, and then I put 1 star because you can do this little guy as much as you want. And then you got to go back, 0, 1, all right? What's slightly wrong about this is actually you don't even need to do this part of the loop at all. You could just go 1 followed by 1. And in fact, you could do the 1 and then you could go around this many times and then go back to the last one. So actually the proper answer is this, like so. You got to do the first one and then you can do this part as many times as you like. And what this part is 0 followed by a bunch of 1s followed by another 0. And then you got to do the last one to get back to the beginning. And then all of that, you could do that several times. But anyway, this is the regular expression which generates all possible binary numbers that are divisible by 3. I think that's cute, right? What we're going to talk about next, this was the last example of this kind of regular expression thing. I just want to encourage you to think of regular expressions. Usually we think of them as descriptions of strings, but another way to think of it is like a little computer. This thing right here is like a little computer. I think maybe that's all I wanted to say for today. What we're going to talk about next time and the next few times is non-regular languages. Languages which you cannot make using NFA, DFA, or regular expressions. All right, I think that'll do. There's no sense in me spending 1 minute more to talk about it. See y'all next time. I am happy to talk about homework questions if anybody's got them. I did a few at the beginning and I had to stop, so if there are more, let me know.